Okay, it's baseball season. Let's find the distance from home plate to second base on a baseball diamond. Is a baseball diamond really a diamond? It's a square, right? Yeah, well, yeah, you're right. But we don't think of it as a square. Let's see. Now, let me tilt my head to make sure I'm drawing a square. Does that look like a square? If you tilt your head, does that look like a square? I think so. Oh, come on. Let's pretend like that's a square. You're right, it may not be perfect. On my screen, it looks okay. Actually, sometimes it gets stretched out on the projector. You're right, it doesn't look as good on there as it does on my screen. But we'll say for the sake of argument that these are right angles here. Okay, and if one of them is a right angle, they're all a right angle. So we'll say this is our baseball diamond. The trick is knowing that a baseball diamond is really a square. Anybody know the length from like home plate to first base or between the bases in general? 90 feet. 90 feet. So it's 90 feet between all the bases. But we want to go from, like, this is like how far does the catcher have to throw to throw out a base stealer, right? So the catcher is actually right here. We'll say he's right at home plate for the sake of argument. There's home plate. Here's second base. So if the catcher is throwing somebody out, he has to throw that distance in red right there. But if you tilt your head, don't you have yourself a right triangle? So let's cut out that right triangle. So that piece in red and tilt and rotate it. So there's that distance in red. And it's supposed to look like a square, or half of a square. There's first base right there. Okay, we know that the lengths of the sides are both 90 feet. 90 feet. And so we just need to find the length of that hypotenuse. We'll call it C. So yet again, Pythagorean theorem, right? In fact, it's not even a very hard one because you're going to have C squared isolated. What does C squared equal? In this case, what does C squared equal? 90 squared plus 90 squared, right? So 90 squared plus 90 squared. Okay, you want to see, now you could just square 90 twice, add it together, and then take the square root of both sides. But if you want to simplify the radical, here's an easier way, and it's going to look weird, but if you think of it this way, couldn't you think of 90 squared as 1 times 90 squared? Isn't that the same thing? I mean, it's a weird way to think about it. Why would you do that? But couldn't you think of it that way? So what is 1, if you think of 90 squared as like your x, what is 1 times 90 squared plus 1 times 90 squared equal? If you want to keep the 90 squared around, doesn't it equal 2 times 90 squared? Now, you say, why, Mr. Chamberlain? Why are you torturing my eyes with this? Why are you doing that? Well, because now when you take the square root of both sides, you can simplify the radical because you already have the 90 squared there, right? You can pull out the square root of 90 squared. That's the reason. So if you want an exact answer, this is a nice way to do it. Take the square root of both sides and then simplify the radical as usual. And you know, to simplify the radical, you pull out the square root of the perfect square, right? So that pulls out, what do you get on the outside then? You get the square root of 90 squared, which is 90. So you get 90 outside the radical. What's left inside the radical? Square root of 2. So you get C on the left side is equal to 90 root 2. What units are we in? Feet. And then it might be nice to get a decimal approximation of that, right? So 90 times the square root of 2. About 127 point, let's go to one place past decimal, so 0.3 feet. 127.3 feet. Okay? That makes sense why I did that weird way? Because I knew I wanted to simplify that radical. If I didn't care about simplifying the radical and just getting an approximation, it would have been easier actually to just take 90 squared plus 90 squared on the calculator and then take the square root. But if you want an exact answer, the way I did it was easier.